Hello guys. Okay, so now I hope you guys have gone through the first part of this video, of 10.2 exercise explanation. We are going to start with the second part of this explanation. Okay, so let's see what. Okay, so in this part we are going to see what is called condition of collinearity. Now what do you mean by condition of collinearity? Just see if let's say this is our vector. Okay, we have this is our A vector and we have another vector. Let's say this is B vector. Correct. Let us write a statement, okay, that if two vectors, say A vector and B vector, A vector is equal to B vector. If two vectors are equal, say A vector is equal to B vector, such that their unit vectors are equal, such that their unit vectors are equal. करेक्ट, उनके यूनिट वेक्टर्स क्या है, इक्वल है. करेक्ट, मतलब that means what are we talking about? If this is vector, if I say that the unit vector of this is going to be a cap, that means if I am saying that the unit vectors are equal, that means the unit vector of this will also be a cap. Correct? Okay, then if two vectors, say a vector is equal to b vector, such that their unit vectors are equal, then we have, what do we have? Then we have a vector is equal to magnitude of a vector into a cap. See, listen guys, this entire vector is made of multiple caps, correct? A cap, a cap, a cap, a cap. That means this entire vector, this entire vector is made of multiple a caps, correct? A cap, some units of a cap. That means if you want to find out what is the length of this entire vector, or we can represent this entire vector also by saying that it is equal to a cap into the magnitude of this vector. If it is 7 units, then it is 7 into a cap. Are you getting it? So that means we can say that this is, sorry, all right, so we can say that this is equal to a vector is equal to magnitude of a vector into a cap. Now similarly, because the unit vectors are same, we can say that b vector is also equal to what? B vector is also equal to the magnitude of b vector into a cap, because their unit vectors are same, correct? Now if we carry this further, this will give us what? This further will give us that a vector by magnitude of a vector will give us a cap. Let's say this is your one statement, and this will give us what? This will give us b vector by magnitude of b vector will give us a cap. So this is your statement 2. Now both are a cap, so we can easily equate 1 is equal to 2, correct? We can say 1 is equal to 2, right? Now that means we can write down now that a vector by magnitude of a vector is equal to b vector by magnitude of b vector, correct? This will get us where? That means I can represent my a vector as, a vector is equal to magnitude of a vector divided by magnitude of b vector into b vector. Perfect? See, listen guys, magnitude is some quantity, correct? Magnitude एक number है ना? Magnitude is a number, correct? Now going ahead, so if I say this, that means this particular thing, if you say this is some constant a b c d e f g h I j k l m, any constant, correct? This is some constant, but in NCERT there is a specific term that you have used for this constant, which is lambda. Okay, that means we can say that considering magnitude of A vector by magnitude of B vector is equal to some constant value, say lambda, then therefore what we will have? Therefore we will have that A vector is now equal to lambda into B vector. Yes, I hope. Correct? I hope everybody is getting it. Right? This is one way of looking at it, correct? Or this is one condition of first condition of collinearity, we can say, where A vector can be represented as lambda into B vector. Okay, if two vectors are collinear, right? If they are equal in such a fashion that their unit vectors are same. See, now if we have any other vector in the opposite direction, then what will happen? Remember, both these vectors are in the same direction, correct? Now we can have vectors in the opposite direction, correct? So if the vectors are opposite, what will happen if the vectors are opposite? We saw a vector which both the vectors are in one direction. But then there is also a possibility that this vector is like this. You have the A vector which is going in this direction, correct? And you have another vector which is going in this direction, correct? That means if, see, even if I say that this is B vector, okay, that means what? Or let us say that this is C vector. Let us take this as another vector, because we took B vector which was going on the same direction. So let us take that this is some C vector. Now C vector is going in the opposite direction, which means what? If this is your A cap, correct, this from here will become negative A cap, correct, because it is going in the opposite direction, correct? Okay, opposite direction. Collinearity, you know, of course they are collinear because direction doesn't matter, right? But yes, the units are going to be opposite. Now which means what can we say here? If this is the case, that means if we have to put up the same theory that we had before, then can we say that, like we said, that this A vector is equal to A vector, magnitude of A vector into A cap, correct? And this will become that C vector is equal to magnitude of C vector into negative A cap, correct? This is equal to negative A cap, correct? Now what is happening here? Can you see? If even if I say, even if we take this C cap, this is if I take this negative sign here, correct, that means it will go to the to this particular value, correct? I can I put this as, let us put it in format of what we had done before. Okay, this will become A vector by magnitude of A vector is equal to A cap, and this will become C vector by magnitude by negative of C vector. This is also A cap, sorry, this has to be a cap. Okay, this is also a cap and this is also a cap. So if you say this is your statement 1 here and this is your statement 2, both are a cap, so we can equate it. So therefore we can say that A vector by magnitude of A vector is equal to minus of C vector by magnitude of C vector, correct? Now can we say, we can do the continue doing the same thing. So then we can say that now A vector is thus equal to, A vector is equal to magnitude of A vector. We will take this negative sign here, minus magnitude of C vector into C vector, correct? Now this is a negative sign. So therefore we will say considering that this negative value minus of negative of A vector by C vector, let us say this is some value called mu. Okay, we say this is as mu, correct? So some value say mu, then how will it look like? Therefore we can say that therefore A vector, this entire negative value, whenever it is negative we call it mu, whenever it is positive we call it lambda, correct? A vector is equal to mu into C vector. I hope you're getting it, right? So basically if this is the, if the vector is, if the vector is negative or the vector is in the opposite direction, then we will use mu, and if the vector is in the same direction, then we will use it as lambda, correct? Just to summarize it once to what we did, okay, that if two vectors, just this is just summarizing to what we did right now, okay, that means what are we saying here, okay, that if two vectors, if two vectors, or if we can say that two equal vectors, if two equal vectors are in the same direction, are in the same direction, then according to condition of collinearity, then according to condition of, according to condition of collinearity, condition of collinearity, what do we say? Condition of collinearity, we can say that, we can say that, listen here now, that we have a vector, a vector is equal to lambda into b vector, this is for same direction, and we can say that, we can say that a vector is equal to mu into c vector, which is, we can say this is, I'm going to put equal to sign or some other sign because, okay, so okay, that means, and this is for what, this is for, this is same direction, or this is for opposite direction, correct? I hope it is clear now, right? Just to summarize to what we did before, okay, this is the first condition of collinearity. What we did right now until now was the first condition of collinearity, okay. We are going to do the second condition of collinearity now. For the second condition of collinearity, we are going to use our inference of the first condition, इसी को यूज करके सेकंड कोलिनियरिटी करेंगे हम. Okay, let us see what is the second condition of collinearity then. The second condition of collinearity के लिए भी हम लोग first condition जो हमने prove किया है, we will use that over here and then we will prove our second condition of collinearity, correct? Now let us say that we have a vector, that if we have a vector A is equal to A1 I cap plus B1 j cap plus C1 k cap, and we have another vector, say B vector, which is equal to A2 I cap plus B2 j cap plus C2 k cap. Now if we state here that, if we say that if A vector and B vector are collinear, correct? If they are collinear, then this condition will apply, correct? Then we can say that, then we can say that according to our first test of collinearity, we can say that A vector is equal to lambda into B vector, correct? We can say this, right? Now let us substitute, I'm going to do it on the other side, okay. Now let us say therefore, since considering that the vectors are collinear, considering that the vectors are collinear, we can say that, okay, so here I'll write down, considering the vectors are collinear, the vectors are collinear. What can we say? We can say that therefore we can put them, we can say in this fashion, okay, that if a vector is equal to lambda b vector. So a vector ka value kya hai? What is a vector? A vector is this whole thing, correct? So can we write it down like this? So we can say that a vector, which is equal to, I'll use another color to avoid confusion, okay, this is equal to a1 I cap plus b1 j cap plus c1 k cap. This is equal to lambda into a2 I cap plus b2 j cap plus c2 k cap. Correct? If we open the bracket on the right hand side, we will get a1 I cap plus b1 j cap plus c1 k cap. This is equal to lambda into a2 I cap plus lambda into b2 j cap plus lambda into c2 k cap. If we compare the left hand on comparison, so we can say therefore on comparison, what do we get on comparison? On comparison we will get something like this. On comparison we will get, if you compare a1 with this one, correct, so we will get that a1 I cap is equal to lambda into a2 I cap, correct. That means if you remove the I on the side, because both are going to be the same units, so we can say a1 is equal to lambda into a2. That means we can say that a1 by a2 is equal to lambda, correct. The same theory we can apply for b and c as well, correct. So let's see what we can do write for b. So we can say here, we can say that similarly we can say that b1 by b2 will give us lambda. On comparison we will get b1 by b2 is equal to lambda, and the last one that we will get will be c1 by c2 is also equal to lambda. Since all of them are equal to one quantity, okay, I am going to write this on this space now, okay, pay attention. So all of them are equal to the same quantity, so therefore we can say that what do we get? We get a1 by a2 can be equal to b1 by b2 is equal to c1 by c2, which is equal to lambda, correct. This is what we understand, correct. All right, this is the second condition of collinearity. What is this? This is the second condition of collinearity. We'll do one example and you will understand a little better, okay. Let's take one example here. Let us say show that vector uh, vector 2i cap minus 3j cap plus 4k cap, and there is another vector they have given which is minus 4i cap plus 6j cap minus 8k cap. Suppose these are two vectors and it is given that they are collinear. They are collinear, correct. If this is the case, then that means now we let us see what we'll just use. This is just an example, okay. So basically क्या आवाज आता रहता है इधर. Okay, let us say this is our a vector, first one, which is 2i cap minus 3j cap plus 4k cap. अगर ये a vector है, and we have our b vector which is equal to minus 4i cap plus 6j cap minus 8k cap. Now we already know that they are collinear. It is given. Therefore, can we say that A vector is equal to lambda into B vector? Okay, we have to find out the value of lambda here. Okay, so therefore can we say that 2i cap minus 3j cap plus 4k cap. Even if you don't want to do all this, okay, we know that, okay, we found out, what do we know here? We know one thing, that a1 by a2 is equal to b1 by b2 is equal to c1 by c2, which will give us the value of lambda. So let's see whether we are getting our value of lambda like this. Just put in the values. Now we know what is our a1, b1, c1. I don't have to do those baby steps here. I think you'll get it very clearly. Okay, so therefore we can say that a1 is what, 2, b1 is equal to minus 4, is equal to, sorry, a2 is equal to minus 4, b1 is equal to minus 3, and b2 is equal to 6, and c2 is equal to 4, and c1 is equal to 4, I'm sorry, and c2 is equal to minus 8. If you check, this will all give you a minus half. Correct, 4 1 the 4 and 4 2 the 8, so this will give you a minus half throughout value. So hence we can say, therefore we can say that lambda, here you got an equivalent value of lambda which is half. So therefore, okay, when lambda comes equal and all of them are equal, okay, so we can say that they are collinear. Correct, therefore we can say that vector A, show that, see the question was show that they are collinear. So if you do this, therefore we can say that A vector and B vector are collinear. Correct, the question was show that vector, these two vectors are collinear. We have to show that they are collinear. Correct, so we took this vector and we tried to put them here and we tried to solve them like this. We got that all of them are equally giving us the same lambda value. Therefore, because the lambda is equal, we can say that the vectors are collinear. I hope you all got this. Correct, ज़्यादा difficult तो ये है नहीं. Correct. All right, so basically this is what it is in terms of using the concept of collinearity. Okay, now the next concept that we are going to learn here is direction cosine and direction ratio. Okay, okay, so let's understand here what is the concept of direction cosine and direction ratio. Okay, now you see, remember in 2D geometry, when we look at 2D geometry, suppose this is our x-axis, okay, and this is our x-axis and this is our y-axis, correct? And then remember that if we have this line, this is some line L, correct? Now here we have learned that slope of this line, which we said that the angle between the positive side of x-axis, that is this, which is the positive side of x-axis, correct? So we can say that the angle with the positive side of x-axis, which is theta, right, and intersecting the line a theta, which will be your tan m. So we can say that this angle, and when we know that this angle is equal to x, then angle with y-axis, that means this angle, see if this is x, then angle with y-axis, this will be what? This will be 90 minus theta, correct? So basically we know, we know if this angle is theta, then this is 90 minus theta. We are able to identify that, and then we say that tan theta is equal to our slope, which is equal to m. And what does slope tells us? Slope will tell us how much the line is bending, correct? This is what we understand, this is what we learn about slope in the 2D form. This is about the 2D form that we have seen, correct? But then does this happen like this in the 3D form? What happens in the 3D form? In the 3D form, we have, this is our y-axis, this is our x-axis, and this is our z-axis. Now in 3D form we can't just have a line. So in the 3D form we always consider one point, okay, where we say this is our point P, which is x, y and z are its coordinates, and this is our origin 0, correct? We know that this line from the origin which touches P, correct? This is what? This is our OP vector, correct? This is our position vector. This is our OP vector, correct? OP vector. Now, even if we know the angle that this vector is making with the x-axis, suppose if you know that this is making with x-axis, it is making some angle. How will it help us? We will still not know, because see, in the 2D part it was easy because the total was 180. But here what are you going to do? Merely by knowing one angle, we will not know what is the measurement of these two angles. We are not able to identify this, correct? Now, for which then we have to define these angles with OP, correct? So how do you define this angle? So let's say here, let us say that the angle made, so let us say that OP vector makes an angle alpha with x-axis, correct? It is making an angle alpha. तो ये जो angle है with x-axis के साथ जो angle है, correct? This is alpha angle. Now it is saying that OP vector makes an angle beta with y axis, correct? So here it goes like this, correct? This will be, okay, let's put an arrow here with the x-axis. Let's put an arrow here. This is going to be y-axis. Y-axis is going to make angle beta, correct? And similarly, we will have the angle now it will going to make angle also with z-axis. So we can say that OP vector makes an angle beta, alpha beta, then we can say that this is gamma with z-axis, correct? So that means this angle it is making with z-axis, this angle that it is making with z-axis, we can say this is what? This is the gamma angle. Is this clear? Has everybody understood this? Simply OP vector is in space, so we don't know we have what is the measurement of the angle for which it is making an angle with every axis is our understanding, and we have called them that these angles are alpha, beta and gamma. Also understand one thing. See, in reality, we do not know the direction of OP vector, boss. We are not aware of this direction. So, exactly to know this direction, इसका direction क्या है? What is the direction of OP vector? To know this OP vector direction, we are defining these three angles, and thus if we take the cos angles, so that cos angles को क्या बोलते हैं? Cosine, correct? And therefore the cosine of these angles, what will they do? Okay, cosines of these angles, what are the cosine of these angles? They are cos alpha, cos beta and cos gamma, correct? You will take the cosine value of all these angles that we have defined, correct? These are the cosine angles. They will define, what will they do? The cosine angles, that is these angles, they will define the direction. They will define what? They will define the direction. They will define the direction, and thus I'll write this thing in another color because the white and white will get all together. Okay, so what are they doing? Therefore these will define, they will define the direction of what? They will define the direction of the OP vector, correct? They will define the direction of OP vector, correct? And therefore they are called as direction cosine. They are called as direction cosine. I hope this is not very difficult to understand, correct? So first of all, there is one point in space. When it comes to 3D, we are not aware of the direction of this particular point, correct? There is this point in space which is in a 3D format. We are not aware, this point can be here, anywhere. We are not aware of the direction of this OP vector. To define the direction of the OP vector, we have to know what angle this particular vector is making with each direction or which its axis. So we are defining that angle as alpha, beta and gamma, and we according to the cosine, according to the cosine value, according to the cos value, according to the cos of that angle, we will be able to identify the direction of this particular OP vector. So we say that cos alpha, cos beta and cos gamma thus are our cosine values, are cosine direction, correct? Or we say the direction cosine, correct? I think until here it's absolutely clear. I don't think there is any chance of any confusion. Okay, now let's go ahead. So going ahead from here, so what are our direction cosines? Let's write them again. So we found out that our direction cosines are direction cosine of OP vector जो हमने अभी देखा, they are equal to cos alpha, cos beta and cos gamma, correct? Now let us say, so if we say, or rather say we can, so therefore we can say we can give them one value, correct? Therefore बहुत डार्क हो गया ना ये, okay, we can say that cos alpha equal to L एक वैल्यू है, correct? Cos beta will get one value which is m, and we have cos gamma say which is n, correct? So now onwards we will call, now on we will call our direction cosines as L, M and N, correct? We will call our direction cosine will be L, M and N, correct? Now on, whenever we say L, M, N, we will understand we are talking about cos alpha, cos beta and cos gamma, correct? Now on, direction cosine will be called as L, M and N. L, M, N and cos alpha, cos beta and cos gamma are absolutely the same thing. I hope you guys have understood this, correct? इसमें कोई confusion का कोई chance ही नहीं है, correct? Let's see now what is the concept of direction ratio, correct? Direction ratio. What do you mean by direction ratio? Okay, now let us say therefore direction ratio of OP vector. I'm going to write the definition here, okay? And they are saying that direction ratio of OP vector are three such numbers, they are constants. So let's say numbers A, B, C such that they are proportional with L, M, N. What does that mean? That means we can say that therefore we can say when they are proportional means what? Proportional means L by A is equal to M by B is equal to N by C, correct? In this case, if this is the condition, then in this case, so in this case we can say In this case, A, B and C are direction ratios of OP vector, correct? Are direction ratios of OP vector, correct? This is the definition. Okay, this is the definition. Oh, definition, I don't know how much you will be able to get it. It's difficult nahi hai. Yeah, but let us do one example, and I think that's how you will get more clarity on how um, we look at it actually, correct? So let us do one example here. Okay. Uh, okay. Let's say write the direction ratios. Write the direction ratios of the vector A vector है ये, which is given to I cap plus j cap minus 2 k cap, correct? And hence calculate direction cosine. Okay, let's do this. See, now first thing first, let us understand that if A vector is equal to x into I cap plus y into j cap plus z into k cap, if this is the case, then we can say that direction ratios of A vector are simply what? Simply x, y and z. Are you getting it? That means any vector in the world, direction ratios are the scalar component. Are you getting it? जब दुनिया में कोई भी वेक्टर होगा, उसका direction ratios will be the scalar component. Coming back, okay. Now we have to do the direction cosine. Okay, we will come back to this question. I'll explain this a little bit and then we will come back to the question. Okay, now how to do the direction cosine? Direction cosine कैसे करेंगे? देखो, first of all we have to find the A cap to find direction cosine. To find direction cosine. To find the direction cosine, what you will do? First step one, we have to find A cap, correct? You have to find A cap. How will you find A cap? A cap का formula है हमारे पास. A cap is equal to A vector by magnitude of A vector, correct? Now यहाँ पर what is our A vector? That means A cap will be, this is equal to A vector का we have I cap, no, x I cap, sorry, we are doing this green part, not the this. Okay, this I will put this as explanation. We will do the sum again. Okay, this is the explanation. Understand the concept first. Okay, now so we can say that our vector is equal to x I cap plus y j cap. Look at the green one. Okay, the white one I am yet not explaining. Okay, k cap divided by magnitude of A vector, correct? Now if I separate this with each one, then can I say that A cap is equal to x by magnitude of A vector I plus y by magnitude of A vector j cap plus z by magnitude of A vector k cap. We can say that, right? Okay, that means directions. Abhi now, what is the scalar component of A vector? What are the scalar component of A vector? Tell me. Scalar component of A vector. One second. Let us just partition the board. Okay. Therefore, we can say that the scalar component of A cap, not A vector, sorry, the scalar component of A cap. Scalar component of A cap is equal to x by magnitude of A vector, then y by magnitude of B vector, and z by magnitude of all are A vector, why B vector, okay, A vector, and z by magnitude of A vector, correct? So these are the scalar components, correct? Now that means what they will become? These will become what? Which means they will become the direction cosines. They will become the direction cosines. Therefore, these are what? These are the direction cosines of A vector. Are you getting it? I hope you are getting it. Correct? Scalar component of A cap. Right? They will become the direction cosine. So therefore, we got our direction ratio. एक बार देख लेते हैं. That means we have our direction ratio यहाँ पे इस वेक्टर का, which is x, y and z, and direction cosine is equal to x by magnitude of A vector, y by magnitude of A vector, and z by magnitude of A vector. Getting it? Okay, चलो now we'll go back to this question. Write the direction ratio of the vector. ये question लिख के रखना है. I'm directly solving it on the next page. Back to the question. 2 ही मिनट में solve हो जाएगा ये. Correct? So if you've understood this, I can just erase this and do the question there. Oh, I'll keep the explanation, let it be. So what was it in the last question? We have coming back to the question. So let us say back to the question. Okay. The question is gone on the previous slide, but I will just write what is the vector that they have given you. That A vector हमको दिया है, which is equal to I cap plus J cap minus 2K cap. So first thing, what is our direction ratio? What is our direction ratio? Direction ratio will be direction ratio. Scalar component of this A vector. Scalar component of A vector is equal to 1, 1 and minus 2. So this is your direction ratio. Now we have to find out direction cosine. Correct? Now direction cosine is equal to what? Direction cosine is equal to x by magnitude of A vector, y by magnitude of A vector, and z by magnitude of A vector. Correct? Now first of all, then we have to find out what is magnitude of A vector. So let's figure out what's magnitude of A vector. Therefore, magnitude of A vector is equal to what? Is equal to under root of 1 square plus 1 square plus minus 2 whole square. Now this is equal to 1 plus 1 plus 4, which is equal to root of 6. Correct? Alright, this is what we are looking for. Alright, now let's continue this on the other side. So then can we say therefore we can say that what is our direction cosine? Therefore direction cosine is equal to, see direction cosine क्या है अपना? L, M and N. So now what is our L? L will be 1 by root of 6. Correct? This is your direction cosine. 1 by root of 6. Again 1 by root of 6. Na? This and this. Correct? And then this will be what? Minus 2 by root of 6. Remember, these are our direction cosines. Correct? Now check if L by A. Okay, we can check it by yourself. हमको check क्या करना है? We have to check. See, check for yourself. Check करो that whether L by A is equal to M by B is equal to N by C. A B C हमको पता है ना क्या है? L is this and A B C is this. Correct? See, this is L M N and A B C. Correct? So we will just substitute the values here and you will see. Okay, क्या आता है देखो. So we have 1 by root of x divided by 1. Okay, this is equal to 1 by root of x divided by 1. This is equal to minus 2 by root of 6, sorry, everywhere I said x, no, by mistake, it is actually 6 divided by 2, correct, divided by minus 2. What will you get? Check करो ये सारा, ये कट हो जाएगा ना, will it be equal, all of them, are they equal or no? ये 1 निकल जाएगा और ये 2 और ये 2 भी कट हो जाएगा. You will get 1 by root of x is equal to 1 by root of x is equal to 1 by root of x, correct? So if you check, we will understand that they are all equal, right? So this is what it is. This is what we call as direction cosine and direction ratio. This is how we will be doing the sums based on direction cosine and direction ratios, and henceforth for direction cosine direction ratio we'll always say dr and dc instead of writing the whole thing. All right, okay. Now we are going to check what is section formula. Section formula के 3 parts है. One part is internally, one part is the midpoint, and one part is the external. ये हमको पता है पहले से, correct? Okay. Let's say we have a line. Okay. Let's name this line as say P and Q. Okay. Let's say there is a point on this line. Okay. This is in 3D space. I have not drawn the 3D, but ये 3D 2D में नहीं है. 2D हमारे पास already formula है 2D का, correct? This is a 3D space that we have where we are dealing with vectors, correct? Now we have to, okay, we have to find out what is the ratio. Okay, now imagine that there is a vector. Suppose this is, these are the 3 vectors from a single initial point, same hai, these are the 3 vectors we have, correct? Now that means this is going to be your, let's say, a vector, this is going to be your b vector, and let us call this as our r vector, and let us say this is point r. Okay, that means we can say that pq is divided internally by point r. PQ is divided internally by point r, and this vector is r vector, therefore this is your r vector, correct? Now the statement that we have to show here is r divides, if r divides PQ in m is to n ratio. Here we are only talking about internally, correct? So now therefore we can say let a vector be the position vector of point P, correct? Position vector of P, point P, and B vector be the position vector of point Q, correct? Then to find the position vector of R, therefore we can say that R vector, I'll write it in red color since we have used it, R is red color, what's wrong? Okay, so we can say that therefore then R vector will be, how will you find out R vector? That is M into B vector plus N into A vector divided by M plus N. Section formula जो हम लोग पहले भी use कर रहे थे same type है, but this is vector, so we are going to find out the R vector, correct? To find out this vector we have to use this formula. To find out this pink color line, to find out the pink vector, okay, we have to use this particular formula. Okay, I hope you have understood this. Okay, let's go to the next one. In the next one we have the section formula, which will be the midpoint. A midpoint maybe I'll first quickly say that suppose this is our line and this is our line again, P and Q, correct? And here also we have taken that this is a point, this point is approximately in the middle, correct? And then let's draw the vectors which are joining these points, correct? So these are the vectors. R is a midpoint, so here we are going to say that R is a midpoint. What is R? R is a midpoint of PQ. Correct? Something is wrong with the pen. Okay. Therefore, then can we say that therefore PR sorry, therefore PR is to PQ कितना आएगा? Therefore PR is to PQ is always, it will be in the ratio of 1 is to 1 since it's a midpoint. Correct? Then it becomes very easy. देखो, this is your A vector, this is your B vector, and this one here is your R vector, this is your R point. Correct? तो यहाँ पर then we can find out our R vector very easily, which is equal to A vector plus B vector divided by 2. Correct? Same section formula if you remember. Correct? Very easy, I hope. Right? Okay, let's see the last one, which is the section formula, which is external. Okay, what do you mean by external? What are we trying to say here? In external, we are trying to say that your M is going to be greater than your N. Okay, let's see how our figure will look like. Suppose we have this point, say P and Q. Okay, we have this is P and this is Q. Now, there is one point which is lying outside P and Q. Okay, and let us say this is our point R. राइट नाउ देखो, ये वर्ड जो डिवाइड हम लोग यूज करते हैं ना, ये एक्चुअली डिवाइड नहीं होता है. दिस इज एक्चुअली द रेशियो बिटवीन व्हाट, रेशियो बिटवीन दिस एक्सटर्नल पॉइंट एंड द लाइन दैट वी हैव. करेक्ट? दैट इज द रेशियो. तो here we have to find out every time, all the three cases we are finding the ratio of PR is to PQ. That is what we are doing. ओके, नाउ लेट अस ड्रॉ. सी, ये सारे वेक्टर्स हैं हमारे, लेकिन ये जो डिस्टेंस है ना, ये अलग से है. गेटिंग इट? सो हियर नाउ वी से दैट दिस इज योर ए वेक्टर एंड दिस इज योर बी वेक्टर. तो अकॉर्डिंग टू व्हाट वी हैव बीन डूइंग अंटिल नाउ, वी हैव बीन टेकिंग दिस इज आवर आर वेक्टर. Correct? And we have always been saying that R is the point which is dividing, R is the point which is dividing. That means, can we say here now that R divides, we can say here that R divides, डिवाइड मतलब रेशियो ही होता है, क्योंकि हम रेशियो को डिवीजन फॉर्म में भी लिखते हैं. दैट इज वाई R divides PQ in M is to N एक्सटर्नली. करेक्ट? यहाँ पे आई एम राइटिंग एक्सटर्नली. पहला वाला केस था हमारा विच वॉज इंटरनली बिकॉज इट वॉज लाइंग ऑन दैट. अब यहाँ पे क्या हो रहा है? इट इज लाइंग आउटसाइड द लाइन एक्सटर्नली. सी, एज आई सेड बिफोर, अपना our ratio every time has been what? Our ratio every time has been PR is to PQ. So here also we have to see PR is to PQ. Correct? That is what we have to see. Right? Now, therefore, our ratio will be what? Let us write down. Our ratio is equal to PR by PQ. Correct? That means it will become what? It is greater. Correct? Now, this will be, say it is going to be 2. अगर ये 2 है तो ये 1 हो जाएगा ना. Getting it? Let's say it is 1. I mean, I'm just giving you an example. और let's directly put external, सबको रेशियो पता है, ये हमने किया है वो. So here we can say that therefore R vector is equal to M into B vector minus N into A vector by M minus N. You know, if this is 2 then this is 1. That the ratio 2 is to 1 हो जाएगा. That was I was trying to tell. That is what I was trying to tell you guys. Correct? But anyway, we'll avoid the I mean to say that PR will always be greater than PQ when the point R lies outside the line PQ, obviously. Correct? So this is how we find out our ratio with the external or internal the formulas are what we have been seeing right from grade 10, तब से देखने आ रहे वही formulas है. Okay, let's do this example. See, consider 2 points P and Q with position vector OP, which is 3 into A vector minus 2 into B vector, and OQ is equal to A vector plus B vector. Find the position vector of point R which divides the line P and Q in the ratio 2:1. Here we are going to do internally and externally both. Okay, internally and externally both. Correct? So दोनों मिल we will find out both. Okay, all right. So first of all, internally and externally. All right, let's do this. पहले तो डायग्राम देखते कैसे आएगा. What are they saying? Consider 2 points P and Q. मतलब क्या? तो suppose this is our point P and say this is our point Q. So if you can join this point, correct? Now they are saying that with the position vector OP, तो ये आपका पोजीशन वेक्टर है यहाँ का और इसका ये पोजीशन वेक्टर है. और should I use the same color that I have been using before? Okay, so this is your position vector. Okay, and this is your position vector for Q. ये एक केस है, right? So ये position vector what they have given, this is O. So what they have given, this is equal to 3A vector minus 2B वेक्टर और ये हमको दिया है A वेक्टर प्लस B वेक्टर. करेक्ट. अच्छा, इंटरनली का केस है. पॉइंट R कहाँ पर है? ये पॉइंट R यहाँ पर है कहीं तो, एंड दिस इज गोइंग टू बी आवर R वेक्टर. करेक्ट. दैट मीन्स इंटरनली अगर है तो वी नो आवर फॉर्मूला फॉर इंटरनली R वेक्टर. व्हाट इज द फॉर्मूला फॉर इंटरनली R वेक्टर? वी से M. अच्छा, हमको m नहीं पता है यहाँ पर क्या, या 2:1. करेक्ट. सो m b वेक्टर प्लस n इंटू a वेक्टर डिवाइडेड बाय m प्लस n. करेक्ट. तो यहाँ पे व्हाट विल बी आवर r वेक्टर नाउ? देयरफॉर r वेक्टर इज इक्वल टू, सी व्हाट इज योर m? m इज इक्वल टू 2 एंड n इज इक्वल टू 1. करेक्ट. यहाँ पे दिया हुआ है, हियर वी हैव इट. Okay, so we can say that 2 into b vector. B vector is what? A vector plus b vector plus n into, what is that? A vector. A vector is 3A vector minus 2B vector divided by m plus n. n is equal to 1, sorry, n is equal to 1. Correct. यहाँ पे दिया हुआ है. Correct. I hope everybody is paying attention to this, that our m is equal to 2 and n is equal to 1. This information is given to us. Okay, and divided by what? We are going to divide it by m plus n. M plus n is 2 plus 1, which is going to be 3. Correct है ना? m plus n, baby steps करे क्या? 2 plus 1. Okay, then r vector is equal to what? R vector is equal to 2A vector plus 2B vector minus 3A vector minus 2B minus 2B vector, sorry, yes, divided by 3. That means this and this will cancelled. Correct. And we will have what? This is plus, sorry. Okay, so this is 2 plus 3. So R vector will be what? R vector will be 5 by 3A vector. This is your answer internally. Getting it? Okay, this is internal case. Okay, अब external case क्या करना है? External case I'll go to the next page and do it. Question तो यही है हमारे पास, right? एक बार diagram draw करके we will be able to get it, right? Okay, now let us see the external case. External case में what they are saying, that ये एक point है P, ये एक point है Q, और दूसरा एक पॉइंट है जो कहाँ पे, यहाँ पर है R. करेक्ट. सो नाउ अकॉर्डिंग टू व्हाट दे हैव गिवन इज ये OP वेक्टर है उसका. करेक्ट. विच इज 3A वेक्टर माइनस 2b वेक्टर अकॉर्डिंग टू द क्वेश्चन, करेक्ट। आप लोगों ने तो क्वेश्चन कॉपी किया होगा, आई कैनॉट गो बैक। ओके, नाउ ये आपका ओ क्यू वेक्टर, ये ओ पॉइंट है। व्हाट इज दिस? दिस इज ए वेक्टर प्लस बी वेक्टर। ढूंढना क्या है हमको? हमको ढूंढना है दिस इज, ये जो आपका आर है, करेक्ट। ओके, दिस इज योर आर वेक्टर, करेक्ट। वी हैव टू फाइंड आउट द आर वेक्टर। अब हमको पता है कि ये लाइन ऐसी है, ओके, और ये पॉइंट यहाँ पे लाई कर रहा है, करेक्ट। तो वी हैव टू फाइंड आउट दिस इज योर एम and this is your n, correct? This is your m and this is your n. Okay, now let's do the sums now. How to do it? Okay, so r vector, अगर एक्सटर्नल है ना, ये केस एक्सटर्नल का है ना, सो आर वेक्टर यहाँ पे m इज ग्रेटर देन n ऑब्वियसली। तो लेट्स सी व्हाट इट इज गोइंग टू बी। आर वेक्टर का फॉर्मूला लिखते हैं पहले। आर वेक्टर का फॉर्मूला इज इक्वल टू m इंटू बी वेक्टर माइनस n इंटू ए वेक्टर divided by m minus n. Okay, now let's use it here and solve the question. So देखो, pr by pq, pr by pq 2 is to 1 दिया है ना, so simply what we will do here, r vector is equal to m will be 2, pr तो 2 ही है ना आपका, वही दिया है ना आपको, so 2 into bracket a vector plus b vector minus 1 into bracket 3a vector minus 2b vector divided by 2 minus 1. So then r vector क्या आएगा आपका? This is equal to 2 into a vector plus 2 into b vector minus 3 into a vector plus 2 into b vector. So r vector will be what? It will be 2a minus 2a vector minus 3a vector will give you minus a vector plus 2 plus 2 will be 4b vector. So this will be your answer, करेक्ट। तो ऐसे ऐसे हम लोग यूज करेंगे एज वी डू। आई प्लीज डू दी एक्सरसाइज सम्स करो, सम्स करो, सम्स करो, करेक्ट। इफ यू डू सम्स यू विल बिकम मोर प्रोफिशिएंट इन व्हाट यू आर लर्निंग। ये करने के बाद इमीडिएटली सम्स करो। ये 9.2 के सारे सम्स आप कर सकते हो आफ्टर यू सी पार्ट 1 एंड पार्ट 2। ओके, ऑलराइट गाइस, देन आई विल सी यू ऑल इन दी नेक्स्ट क्लास, करेक्ट। Let's see you guys again. All right, chalo, bye bye.